So section 1-4 involves solving two-step and multi-step equations. So let's start with example 1. We're going to draw a brick wall to separate the left side of the equation from the right side of the equation. Our goal is to get the variable term isolated on one side by itself. In this particular example, the negative belongs to the 2x, it does not belong to the 6. The 6 is positive, the 2x is negative. So if we want to get the 2x by itself, we need to get rid of a positive 6. The opposite of positive 6 is a negative 6. So we are going to subtract 6 from both sides. The 6's on the right cancel, and then 10 minus 6 here is 4 equals, and we're going to bring down the negative 2x. Now we have just a one-step equation. In order to get the x by itself, we have to undo multiplying by negative 2. So to undo multiplication, we are going to divide by the very same number, very same sign. So we're going to divide both sides by negative 2. The negative 2's on the right cancel. 4 divided by negative 2 is a negative 2 equals x. So our solution is negative 2. So then we're going to check. So let's rewrite the original problem. 10 equals 6 minus 2 parentheses. Instead of the parentheses, we are going to replace x with a negative 2. We're going to perform this part first per order of operations. Negative 2 times a negative 2 is a positive 4. So we end up with 10 equals 6, and then this part right here gets replaced with a positive 4. Then on the right side, 6 plus 4 is 10, so we get 10 equals 10, and it does indeed check. Next problem. So example 2, we are going to solve a two-step equation that involves a fraction. Don't let the fractions bother you. So the easiest way to solve when you have fractions is to get rid of the denominators completely. So if the denominator here is 15, and the denominator here is 5, and this one's 5, the least common denominator is equal to 15. Why is it 15? Because I can multiply 5 by 3 to get 15. We could go through the whole least common denominator part, but by now we should really know that 5 times 3 gives me 15. And so since I can multiply this by something to get 15, 15 has to be our greatest or least common denominator. So if I were you, I would get rid of that least common denominator. We're going to multiply this whole side by 15 and this whole side by 15. To multiply this side by 15, you have to multiply each term by 15. We essentially have to distribute the 15. So we're going to multiply this side by 15 over 1, and then this side we're going to multiply by 15 over 1, and then multiply this side by 15 over 1. So the 15's cancel, and you're left with a q minus the 5 cancels in the 15 3 times, so we end up with a minus 3 equals this 5 cancels in the 15 3 times again, and 3 times 3 is 9. Now we have a simple one-step equation. We're going to isolate the q by adding 3 to both sides. So the 3's cancel, and we get q equals 12. So let's check. Let's take the original problem, parentheses divided by 15, minus 1/5 equals 3/5. We're going to replace our q with what we found out the q would be, which would be 12/15. Since 12/15 and 1/5 do not have a common divisor or common denominator, we cannot subtract them right now. However, this fraction can be reduced. Both 12 and 15 are divisible by 3. 12 divided by 3 is 4, and 15 divided by 3 is 5. And now what that does is it gives us like denominators. 4/5 minus 1/5 equals 3/5. And indeed, 4/5 minus 1/5 is 3/5, and that equals 3/5. So it checks. Problem number 3. Sometimes you have to simplify before you can actually start to solve the equation. So we're going to draw our line to separate the left from the right side. And then look at this left side. We talked about collecting like terms in chapter 6. Well, we're going to take this term right here, 6x, and look for a like term. Remember, like terms are the same variable string raised to the same exponents. This negative 8x has the same variable string x. So all we're going to do is add their coefficients. So we've got 6 minus 8 gives us a negative 2x, and then plus the 3 equals 13. Now we have a two-step equation. My goal is to get the variable term by itself. To do that, I have to get rid of a positive 3 by subtracting 3 from both sides. The 3's cancel. I'm left with a negative 2x equals 13 minus 3 is positive 10. To solve for x, divide both sides by negative 2. The negative 2's cancel, and we get x is equal to negative 5. So we're going to check that. Starting in the original problem, 6 parentheses plus 3 minus 8 parentheses equals 13. Replace each of the parentheses, which used to be x, with the value we found for x, negative 5. Following order of operations, we have to multiply these two together and these two together first. So 6 times negative 5 is negative 30, plus 3, and then we have a negative 8 times a negative 5 is a positive 40, equals 13. And then if you add 3 and 40, that gives you 43. A positive 43 and a negative 30, different signs subtract, and keep the sign of the larger. You do indeed get 13 equals 13. Check. Example 4. In example 4, this one tends to be difficult because of this subtraction sign right there. Oftentimes, you only subtract the x, not the 2. In other words, we have to subtract this entire set of parentheses. And technically, what we have in front of the parentheses is a negative 1. That didn't come out very well. And so we have to distribute a negative 1 through multiplication into everything inside those parentheses. So when we clear the parentheses, we get 9 equals, the 6 didn't change, but the negative times the x is a negative x. The negative times the positive 2 gives us a negative 2. Now, like the previous problem, we've got some like terms, but this time they're on the right side. We have a constant of 6 and a constant of negative 2. So these two items are like terms. So on my left I have 9. The 6 minus 2 is 4, and then don't forget the minus x. So now we're going to get the minus x by itself. Whoops. Let me undo that. This negative sign right here belongs to the x. I want to make sure that I circle the entire term. And that means that I want to get rid of a positive 4. The opposite of positive 4 is a negative 4. So minus 4, our 4's cancel. And we end up with 9 minus 4 is 5 equals, bring down the negative x. Well, we've solved for x, but we haven't solved for a positive x. We still have this pesky little negative there. Again, technically with this negative, this is a negative 1 times x. So if this is a negative 1 times x, to undo multiplying by negative 1, you should divide both sides by negative 1. And so what you're left with is a negative 5 equals a positive x. And that is our solution. So let's check it. In the original problem, we have 9 equals 6 minus parentheses, And this time I'm going to just leave a space because I already have parentheses. So in that space, I'm going to replace it with the value we came up with for x. So order of operations say that we have to do what's in parentheses first. So I'm going to rewrite the 9 equals 6 minus, and then the negative 5 plus 2, different sign subtract, we get a negative 3. I don't know why I just put parentheses there. Let's take that away. And so we have to do, this is a subtraction problem, so we have to change it to an addition problem by doing keep, change, change. So we're going to keep the 6, change subtraction to addition, and change the sign of the number that follows it to a positive. And so the left we have 9, but the right, 6 plus 3, is also 9. So it checks. And so we're going to stop here. There are 2 more pages of slides, but we're going to ignore those, and this is the end of this lesson.